Hello friends, today we discuss Avl tree. What is Avl tree? It's a binary search tree with balance factor. Now there is no any full form of Avl tree. Its name is a honor of from its inventors. A for Adelson, Walensky and Landis. Okay. Now as we know binary search tree, that means the left node has value less than the root node and right node has value greater than the root node, and this is applicable for all the subtree. Okay, so that is binary search tree and balance factor. Okay, now in AVL tree, if balance factor of any node is -1, 0 and 1, that means tree is balanced, and if balance factor is not -1, 0 and 1, that means tree is not balanced. Okay, and if tree is balanced, then this balanced tree is called AVL tree. Okay, so AVL tree is binary search tree with balance factor -1, 0 and 1. Definition of AVL tree is AVL tree is a binary search tree with all the nodes have balance factor -1, 0 and 1. Okay, if tree is not balanced, then we have to balance the tree using rotation. Okay, if any node has balance factor -1, that means the tree is left heavy. If any node has balance factor of +1, that means tree is right heavy. If any node has balance factor 0, that means tree is balanced. If at the left node and right at the left subtree and right subtree, both subtree have same number of nodes. Now how we find balance factor? Balance factor is height of left subtree minus height of right subtree. Okay, if consider the subtree is x, then if we want to find out balance factor of x subtree, then height of x subtree, height of x left child minus height of x of right child. That means height of left of x subtree minus height of right of x subtree. Okay. Now consider this example. If we want to find out balance factor of 7, then first find out height of left subtree. So height of left subtree is 1 and 2. That is 2 nodes in left of 7. So height of left subtree is 2 and height of right subtree, we have to consider maximum path. Here 1 and 2. This is 1, 2 and 3. So height of right subtree of 7, that is 3. So 2 minus 3, that is -1. Now balance factor of 3, that is 1 minus 0 equal to 1. Balance factor of 12, that is height of left 1, 2 and height of right 1. So 2 minus 1, that is 1. For 10, 1 minus 1, that is 0. For 20, 0 minus 0. Same way 9, 0, 11, 0 and 2, 0. Balance factor of leaf node is always 0. Now the balance factor of this root node is 1, 2, left hand side 2 and right side 1, 2 and 3. So 2 minus 3, that is -1. Balance factor of this node is 1, because 1 minus 0, that is 1. Balance factor of 5 is 0. It's leaf node. Okay. Balance factor of this node, left height of left subtree, that is 1, 2. Height of right subtree is also 1, 2. So 2 minus 2, that is 0. Balance factor of this node is 1 minus 0. Sorry, 0 minus 1, that is -1. Balance factor of this node is 1 minus 0, that is 1. And balance factor of these two nodes are 0, because this is leaf node. Okay. Now this two tree has all the node which have balance factor -1, 0 and 0. These two trees are called AVL tree or balance tree. Now consider this tree. Balance factor of 100, 1, 2, 3 and 4. Height of left subtree, that is 4, and height of right subtree, that is 1 and 2. 4 minus 1, 2, 3 and 4, and here 1, 2 and 3. Consider maximum path. So 4 minus 3, that is 1. Now for this node 1, 2, 3 and right 1. So 3 minus 1, that is 2. For this node 1 and right 1, 2. So 1 minus 2 minus 1, 0, 0 is 1 and 0, 1. For this node 1, 2 minus 1, that is 1. Here 0 minus 1, that is -1, and for this 0. Now this node has balance factor 2. Okay, so this tree is not balanced tree because this node has balance factor other than -1, 0 and 1, and this node has balance factor 2. So this node is also called a critical node, and this tree is called not balanced tree or not AVL tree. So for this to make this tree AVL tree, we have to apply rotation on this tree. Now there are 4 rotation to balance the tree: LL, RR, LR and RL. Now this rotation is divided into two parts: single rotation and double rotation. This LL and RR are single rotation and this is applied on child node of critical node. Okay. And this RL and LR rotation are double rotation, and this is first rotation is applied on grandchild of critical node and second rotation is applied on child node of critical node. Okay. Now left rotation. Okay. Now consider this tree. 9 has balance factor -2 because left has 0 and right height 2. So 0 minus 2 minus 2. 15, 0 minus 1. 0, 1, that is -1. For 22 it's 0. Now this 9 has critical node. This 9 is critical node because it's have balance factor -2. Okay, so this is not AVL tree and this is right heavy tree. New node is inserted at right part of right subtree. Okay, so rotation is applied, LL rotation, because this is right heavy subtree and new node is inserted at right part of right subtree. Okay, now we have to apply left rotation. So it's a single rotation because this is our new node is inserted at right part of right rotation, right part of right subtree. Okay, it's same path, R. Okay, now this is single rotation, so it's applied on child node of critical node. So child critical node is 9, its child node is 15. So 15 is rotate left side, so 15 will be replaced by this 9. Okay, so 9 will be replaced by 15. So 15 will be root node, 9 will be again rotate left. So it's left of 15 and 22 is right of 15. Okay, so this is now balance factor of 15 is 0. This node is also 0 and this node is also 0. Now this is AVL tree or balanced tree. Now right rotation. Okay, so consider this tree. Okay, so 15 has balance factor 2. This has 1 and this has 0. So this tree is not balanced tree. Now we have to apply rotation. Now how we find which rotation is applied? So consider last node which we want to insert. So 4 is inserted at last and this 15 is critical node. So new node is inserted at left part of left subtree. So this is left heavy tree. So for to make a balance we have to move some node at right side. So new node is inserted at same direction, left part of left subtree. Okay, so we have to apply R rotation. So RR rotation is again single rotation and applied on child node of critical node. So 15 is critical node and 9 is child node. Okay, so 9 is moved to at root node. So 15 will be replaced by 9 and 15 is greater than 9. So right side of 9 and 4 is less than 9. So left hand side of 9. And now balance factor of all these nodes is 0. Okay, so now this tree is balanced tree or AVL tree. Okay, now single rotation example. Now create a AVL tree using 1 to 7 numbers sequentially. Okay, now 1, insert 1, tree is balanced, insert 2, tree is again balanced, now insert 3. If you are insert 3, then 1 has balance factor 0, minus 2, that is minus 2. 2 has balance factor 0, minus 1, that is minus 1, and 3 has 0. So 1 become critical node. Now new node 3 is inserted at right part of right subtree. Okay, so LL rotation is applied and LL rotation is single rotation applied on child node. So 2 is become root node, 1 is again left of 2 and 3. Okay, now 0, 0, 0. Balance factor of all node is 0. So tree is balanced. Now insert 4. If we are inserted up to 4, then tree is balanced. If insert 5, if we are inserted 5, then balance factor of this 2 is 1 and 1 minus 3, that is minus 2. Balance factor of 3, 0 minus 2, that is minus 2. Here minus 1 and 5, 0. Okay. So now 2 and 3 has balance factor minus 2 and minus 2. So 2 node are critical node. Now we have to consider critical node is 3 because consider last inserted node. So move from leaf to root. Which one is critical node first come, then we have to consider that critical node. Okay, so only balance these 3, 4 and 5, then tree becomes balanced tree. Okay, so new node is inserted at right part of right subtree of this critical node. Okay, so we have to balance apply LL rotation, that is again single rotation. So rotate this 4 at in the place of 3, and 3 is less than 4, so at left and 5. Now tree is balanced. Again insert 6. If we are inserted 6, then 2 will become critical node. 2 has balance factor 1 minus 1, 2, 3. This minus 2. Okay, now new node is inserted 6 at the right part of right subtree. Okay, so apply LL rotation. So 4 will be root node and 2 is left of 4. 5 and 6 as it is right of 4. Now 3 is left of 4. So we are inserted left of 4, but there is 2. So 3 is greater than 2. So right side of 2. Okay. Now this tree is balanced. Now insert 7. If we are inserted 7, then this 5, 6, 3. This subtrees become unbalanced. Again 7 is inserted at right part of right subtree. Okay. So balance this tree. So 6 will be in place of 5. 5 will be left of 6 and 7 will be right of 7. Now tree is balanced and this tree is called AVL tree. Now LR rotation, it's double rotation. That means we have to apply 2 rotation to balance the tree. If we do not want to apply 2 rotation, then we can also combine 2 rotation into 1 rotation by replacing grandchild node with critical node. Okay. Now see double rotation. Okay. Now this 2 is this 3 is critical node because it have balance factor 2, and new node is inserted 2 because last is inserted 2. So new node is inserted at right part of left subtree. Okay, right part of left subtree. So it's LR rotation. First we have to rotate or apply L rotation. So L rotation. So first LL rotation is single rotation, and we have to apply on its critical node. So 1 will be here and 2 will be here. Now second rotation is R rotation. Okay, so 1 will be rotate right. So 1 will be in place of 2 and 2 will be in place of 3. So 2 will become root node. 3 is greater than 2. So at 3 and 1 at left of 2. If we want to combine these two rotation, then simple replace this new node with grandchild node of critical node with critical node. Okay, grandchild of critical node, that is 2, and critical node this 2. So replace 2 with 3. So 2 become root node of this tree, and 1 is also left hand side as it is. And this 3 is greater than 2, so it's move at right side. Okay, so if we want to combine these two rotation, then replace this grandchild node of grandchild node with its critical node and arrange the remaining tree as a binary search tree. Okay, now RL rotation. New node is inserted at left part of right subtree. Okay, so RL rotation, left part of right subtree. Okay, so again these two rotation are there, first RR then LL. So RR rotation, first rotation is applied on grandchild of critical node. So grandchild is 2. So 2 will be replaced rotate. So 2 will be rotate right. So 2 will be in place of 3 and 3 will be rotate again right. So this tree is comes. Now LL rotation. So its second rotation is applied on child node of critical node. So this 2 is child node of critical node. Rotate left 2. So 2 is here, 1 left and 3 as it is. Okay. If we want to combine these two rotation, then replace this grandchild node of critical node with critical node. So 2 will be become root node. So 2 will be here, 1 is less than 2. So at left side, and 3 is greater than 2 at right side. Okay. Now one example, create AVL tree using 1 to 8 numbers. Okay. So first insert 1, balance factor of 1 is 0. Now insert 2, balance factor of insert 2. So 2 is greater than 1. So insert at right side, balance factor of 1, that is 0 minus 1 and 2 is 0. Now insert 3. Insert 3 is greater than 2. So inserted at right side of 2. Now balance factor of 1 is minus 2. That means 3 is unbalanced. So we have to apply rotation. Now how to find which rotation? So consider this critical node and new node. New node is applied on right side of right subtree. So This is R R. New node is inserted at R and we have to apply LL rotation. LL rotation is single rotation applied on child node of critical node. So 2 will be replaced at a root node. So 2 is here and 1 is left of 2. 3 is right of 2. Now 3 is balanced. Insert 4. If we are inserted 4, then again 3 is balanced. Insert 5. If we are inserted 5, then 3 is unbalanced. Here minus 2 and minus 2. Now we are consider which critical node. These two are critical node. We have to come from this 5, because if we are inserted 5, then trees become unbalanced, because up to 4 tree is balanced. Okay, so from start from leaf to root, so this balance, this is balanced. Now this is critical node, so we have to balance only these 3. So consider new node is inserted at right subtree of right part of right subtree. Okay, so it's again LL rotation, so it's single rotation applied child node of critical node. So 4 will be at the place of 3. 3 is less than 4, so at left of 4, and 5 is at right of 4. Now 3 is balanced. Again 6, so this 2 become critical node. Now 6 will be inserted right part of right subtree. Okay, so it's again LL rotation, single rotation. Okay, so 4 will be replaced by 2, so 4 will be here. Now 2 at the left of 4, because 2 is less than 4. Again 1 as it is, 5 and C as it is, right of 5 and right of 4. Now 3. What about 3? 3 is left of 4. So left of 4, but there is already 2 is there. Now it's arranged by rules of binary search tree. So 3 is less than 4, so come in left. 2 is greater than 3 is greater than 2, so come in right. So insert at right of true. Now tree is balanced. Insert 7. If we are inserted 7, then 5 become unbalanced tree. So 5 becomes a critical node and tree is unbalanced. Now apply LL rotation only on this. So 6 will be at 5, 5 left and 7 right of 6. Now tree is balanced. If we are inserted 8, then tree is balanced. Okay. This balanced tree is called AVL tree. Thank you.